Welcome to the session. Now we are going to see about uh, state elimination technique and solve the given finite automata into a regular expression. So the problem here is, this is the state transition diagram. For this we need to find a regular expression for the state transition diagram for this finite automata. So for this we have to use a state elimination rules. So as we discussed earlier in our lecture series, we have seen the rule 1, 2 and 3, and now we are going to see about the solution. Okay, straight away we going to have the solution. So when we see the solution, right, so here now we are having three states. For this we have to eliminate the intermediate states. So what are all the states unwanted? Here we need to eliminate the states. For example, here q1 is the start state, and when we solve this regular expression, for a given finite automata, we need to have the final result based on the result of initial state and the final state. Here both the starting state and final state are the same. Then we have to eliminate q2 and q3. So this will be your final regular expression. So q1, when we solve this here, this will be your final regular expression. Okay, so for this we need to have this cases. So we need to 4 cases to be solved over here. So q1, q2, q3. After that we'll have q3, q2, q1, and q1, q2, q1, and we'll have q3, q2, q3. So here when you see this, we have to eliminate this intermediate state called q2. So when you use this combination, we completely eliminate this q2, and after this, after 4 combination we have found out, the resultant diagram is something looking only it contains q1 and q3. After that we'll have to eliminate q3, and finally we have to find the regular expression for q1. Okay, so we need to find one by one. So first case we have to take this. So case, this is the first one. So q1, q2, q3. So we have to solve this to eliminate q2. So here to eliminate q2, so this is the one. So here, so looking at this transition diagram, we have to make this diagram as per our state elimination rules, right? So q2 is the state to be eliminated over here, and we'll have q3. So q1 to q2, q1 to q2 it goes to 1, and for q2 it is a self state which is known as 1, and q2 to q3 it is 0, right? Okay, when you have q1 to q3 there is no edges like this, and that's it. So as per rule 1, so we have to follow rule 1 for this thing. So already we have seen the lecture series for this kind of how to apply rules for the state elimination technique. So as per rule 1, so we'll have R1, regular expression R1 equal to Rij plus Qi exclosure Pj, right? So there is no Rij, so 5 will be used, and Qi is 1, and here this 1 closure, exclosure, and Pj will be 0. So 1 closure, 0. So here we'll have R1 equal to 1 closure, 0. So this is my R1. Okay, so now we have to go for the second one. So second case, which is q3, q2, q1. So here q3, Q2, Q1. So by referring this transition diagram, it will be look like this: Q3, Q2, Q1. So Q1, it is a self state 0. So we have to refer this one, and we have to redraw as per this transition. Okay. So Q3 and Q3 to Q2, it is 1. Q1 to Q2 to Q1, there is no transition, and Q3 to Q1, there is Q3 to Q1, there is nothing, right? Okay, so only this will be happening. Q3 to Q1, Q3, yes, Q3 to Q1, you will have a 0, right? So 0. So again we have to apply the rule 1. So once again, when we see this, right, so we have to redraw after this rule 1. We have to redraw this diagram like this, something like this: Q1 to Q3, right? So Q1 to Q3, you have this regular expression 1 1 closure 0. So this is 0. That's it. So this is what I just forget that step. So each and every step we have to, after applying rule, we have to redraw this diagram. Okay. So now, as per rule 1, we have to apply here also rule 1. So R2 is equal to Rij plus Qi S closure Pj. Right? What is Rij? So this is 0. So this is Rij. Right? Here this is Qi, and Q2 so Qi is 1, this closure is 1 closure, and there is no Pj, right? As since there is no Pj, you have to make it as 5. So when you apply this 5, entirely it is 5 only, 0 plus 5, which is equal to 0. So then R2 equal to 0. So when we redraw this diagram, Q3 to Q1, right, it is 0. Okay, so this is the redraw after applying rule 1. So this is Q3 to Q1. So we are redrawing this diagram. So next case will be your third one: Q1, Q2, Q1. Okay, what is my Q1? So Q1 will have like this, and Q2 is Q2. This is 1, and this is also 1, right? Q1 1 1, and now this one. So here as per rule 2, we are applying rule 2 here. So since there is only 2 states, we have to apply rule 2. So this is R equal to R plus S. This is not rule 2, this is rule 4, right? SUT. Okay, so here R in this is 0 plus S is 1, U closure 1 closure, and T will be, there is nothing, so it is 5, right? So when you have this 0, so this is R3, so R3 equal to 0. So this is my diagram. So after this one, we have to redraw it, right? So Q1, so when you redraw this one, this is 0. Okay, so now we move for fourth one: Q3, Q2, Q3. So when you have this Q3, Q2, Q3. So when you use this one, Q3, Q2, right? So when you see this Q3, so Q3 to Q2, it is 1, right? And Q2 will have this self state as 1. Okay. After that, Q2 to Q3, 0, right? Okay, fine. So when you apply this rule, R4 equal to, there is no Rij, sorry, there is no R. So here the rule will be R plus SU closure T. So there is no R 5. So S is 1. This is 1 closure and T will be 0. So which means 0, 1 closure 0. So after this one we have to redraw this one. So Q3, when you redraw this, 1 closure 0. Okay. So this is the way we have to redraw this, all these things. Okay. So now we have solved all the 4 possible cases. After that we have to combine all these steps. What are the steps we have done? We have to combine this. Now so this is known as step 1. This is step 1 and this is step 2 and this is step 3. So we have to combine all these one as a step 3, right? So this is step 3. So by combining all the above steps, so the transition diagram will be here. Actually we have eliminated the intermediate state which is known as Q2. Okay. So after eliminating Q2, so after elimination of Q2, okay, follow the steps below. Follow the steps below, right? So here we have Q1 and Q3. Okay. So for Q1 we have to use this one which is known as 0. This is 0. And Q1 to Q3 we have to draw it, right? So Q1 to Q3, see here, Q1 to Q3, 1 closure 0. 1 closure 0. And Q3 will have this one which is known 1 closure 0. See this, 1 closure 0. So this is 1 closure 0. After that Q3 to Q1, right? Q3 to Q1. So it is complete 0. So Q3 to Q1, 0. So now, when you see this diagram, you have to eliminate Q3. Why? Because this Q1 is both the start state and final state. So we need only this state alone, not this state, right? So by eliminating Q3, as per rule 4, we'll have this one. Q1, which is known as regular expression. What is my regular expression over here? R5. So R5 equal to R plus SU closure T. So what's my R over here? So this is 0 plus S, 1 closure 0, U closure 1 closure 0, the whole closure, and T in the sense we have 0. Okay, this is my R5. So once you eliminate this one, step 4 will be if both start state and final state are same, flow 3 is followed, which is equal to R closure, which is known as, so here in this case we'll have R5 the whole closure, right? So this is my R6. So when you apply this formula, 0 plus 1 1 closure 0, 1 1 closure 0 the whole closure, 0 the whole closure. Okay, 0 plus 1 1 closure 0, 1 1 closure 0 the whole closure, 0 the whole closure. So this is my R6. So this is my final regular expression. So this is the way we have to solve. So 0 plus 1 1 closure 0, and we'll have 1 1 closure 0 and 0 the whole closure. So this is the way it has to be done. Okay, so this is my final regular expression. Thank you.